Hello everyone. So in today's video, we're going to present our project for research method, which is early OCD through SVM and naive Bayes. My name is Evan, and this is my partner Goldwin. So let's start, shall we? So the outline for today's video, there's introduction, literature review, methodology, evaluation, and conclusion. Let's start with the introduction. OCD, or obsessive compulsive disorder, is a mental health condition characterized by intrusive unwanted thoughts, known as obsessions, and repetitive behaviors or mental acts called compulsions. These symptoms can cause significant distress and impair daily functioning. Individuals with OCD might engage in behaviors like excessive cleaning, checking, or ordering, often in an attempt to reduce the distress caused by obsessions. Early detection is crucial as it allows for timely intervention and better management of the disorder. Goldwin Hoxenlly, 2018.
Machine learning is a branch of artificial intelligence that focuses on building systems that learn from and make decisions based on data. Two commonly used machine learning techniques is nerve-based and supervised machine. Nerve-based is a simple yet powerful probabilistic classifier based on Bayes' theorem. It assumes that the presence of a particular feature in a class is independent of the presence of any other feature, which simplifies the computation and work well with small datasets. Supervector machines, on the other hand, are more complex. They work by finding the hyperplane that best separate the data into different classes. SVM is particularly effective in high-dimension space and is known for its robustness in handling both linear and non-linear data. This machine learning technique can be highly beneficial in mental health application. They can analyze large datasets to identify patterns and make predictions that might not be obvious through traditional method. This is particularly valuable in detecting mental health conditions like OCD early on, where subtle symptoms can be easily missed.
Using machine learning for early detection of OCD has several benefits. Firstly, machine learning models like naive Bayes and SVM can process and analyze a vast amount of data quickly and accurately. This capability is crucial in identifying the early signs of OCD, which might be overlooked during routine clinical evaluation. Secondly, these models can manage the complexity and variability inherent in psychological symptoms. They can capture subtle patterns and correlation in the data that may indicate the presence of OCD, even in its early stages. Thirdly, implementing machine learning models in mental health care can lead to personalized treatment plans. By accurately diagnosing OCD early, healthcare providers can tailor intervention to be specific needs of the individual, improving treatment outcomes. In summary, leveraging machine learning techniques like naive Bayes and SVM can significantly enhance our ability to detect and manage OCD more effectively and efficiently. Okay, next we got the literature review. Okay, understanding mental health disorder. Understanding mental health disorder is crucial for effective intervention and management. Conducting a study of the epidemiology of OCD using data of the National Comorbility Survey replication, highlighting the prevalence and importance of OCD within the population. This study emphasizes the widespread nature of OCD and the necessity of early detection and intervention. SVM and naive Bayes in mental health detection have demonstrated potentially in the early detection of mental health disorders. Developed an SVM-based model for early detection of depression, utilizing diverse data sources to identify individual risk. This study highlights the efficacy of SVM in handling complex and varied data sets in mental health contexts. Similarly, Han proposed a multidimensional data reduction and evaluation method for assessing quality student mental health using SVM, offering insight into early detection and intervention. Machine learning approaches have shown great promise in clinical psychology. Reviewed various machine learning techniques and their application in mental health research, underscoring their potential for improving diagnostic accuracy. Their findings suggest that machine learning can significantly enhance the precision of mental health diagnosis. The application of AI in healthcare has the potential to transform mental health care delivery. They discuss the possibility and of challenging AI healthcare, emphasizing its role in enhancing clinical decision-making and outcomes. Al-Shadi machine learning techniques, including SVM and naive-Bayes for early detection Alzheimer's disease, showcasing the versatility of this algorithm in diagnosing various brain conditions. Furthermore, ASMA has discussed an automated system for diagnosing mental health disorder using machine learning and sentiment analysis on social media, highlighting the potential data-driven approach for identifying individuals at risk. Thanks. Okay, now I'm going to give the spotlight to my partner for the methodology.
Methodology. First, I'm gonna explain the dataset. Our dataset consists of 24 columns. The target label we aim to classify is the disorder label, which initially comprised 12 different categories. We'll consolidate this into two labels, OCD and non-OCD. This is the list of each correlation between variable from disorder to each of the columns. Pre-processing. In the processing, we do the method, the smart method, because the frequency distribution between the OCD and non-OCD label is imbalanced. So we use the smart synthetic minority of sampling technique method to balance the classes. After that, we do the standardization so that the data more standard and more spread. In training, we split the data into 18% for training and 20% for testing. For classification model, we use machine learning. We use two machine learning techniques: it's supervector classification and Gauss naive-Bayes. For evaluation, we first calculate the ROC plot to visualize the accuracy of the prediction values. Evaluation. First, in here we saw the plot of ROC to Percy curve to visualize the accuracy of the prediction result. And then, additionally, we determine precision, recall, and equivalence score to evaluate the model performance. As you can see, the accuracy for SVC is quite high, is 97%, and for naive-Bayes is quite high also, 98%. This is the confusion mistake that we got. In the left is from SVM and the right is from naive-Bayes. These are the formula that we use to calculate the confusion matrix and the ROC curve.
Okay, let's move on to the conclusion. Our study demonstrated the efficacy of using machine learning models, especially SVM and naive-Bayes, for the early detection of OCD. By pre-processing the data to balance the classes using SMOTE and splitting the data for training and testing, we ensured our model were well prepared to handle classification tasks. Both SVM and naive-Bayes showed good performance with their classification reports and confusion matrices, indicating satisfactory accuracy, precision, and recall. This confirmed that these algorithms are suitable for early OCD detection, facilitating timely intervention and improved patient outcomes. The application of SVM and naive-Bayes in this context highlight the potential of machine learning in enhancing diagnostic accuracy for mental health disorder. By identifying OCD symptoms early, this model can support clinicians in making more informed decisions, ultimately leading to better management and treatment of the disorder. Our findings underscore the importance of integrating advanced computer techniques in mental health care to develop personalized and effective intervention strategies. Okay, that's all for our video. Thank you for listening. Goodbye.